Okay, I have to admit I had a lot of fun with this one. Let's get into it. Question 7. A cylinder has a surface area of 24 centimeters squared. So we've got a cylinder, and so its surface area, if I open that out, it makes a rectangle, and then I'm going to have a lid and a bottom. Imagine a can opening out. Formulae that you know, you learned them in year 8, maybe year 9. Circumference is 2 pi r. So the length around here is 2 pi r. So this length is also 2 pi r because it's going to match onto it. And they've told us that the height of this is h. So we are going to use h. And then we are going to show this. So this was a new line. That's why it went to capital H. It's actually just a little h. Okay. So we know that the surface area of this item, surface area, is going to be the area of each of my circles. We've got a radius of r. So there's 2 equivalent circles, so 2 times pi times r squared. Area of a circle is pi r squared. Hopefully you remember that. An area of this rectangle over here is the base times the height. So it's 2 pi r times the height. Now, they told us that the surface area is 24 centimeters squared. I am now going to solve for h. I'm actually going to rewrite this over here just to give me a bit more space. Okay, so I've just transferred that whole thing of giving myself more space on the left hand side. So the surface area is 2 pi r squared plus 2 pi r, h equals 24. This is the 2 circles and this is the rectangle, and it is equal to 24. So let's just solve that. We are wanting to make h the subject of my formula. I want h equals, I'm aiming for this over here. Okay, so this is all stuck together and it's going to equal 24, taking that to the other side, minus 2 pi r squared. Okay, so then I have got all of this over here. So now I just need to divide both sides by 2 pi r, and I'll end up with h is equal to 24 minus 2 pi r squared over 2 pi r. Well, that doesn't look like this, but can you see I've got a common 2 in here? I can take out a 2, so I can factorize out a 2. Sorry. And that'll give me 12 minus pi r squared over 2 pi r, and 2 divides by 2, and voila, I have shown that the height is given by 12 minus pi r squared over pi r. So that is just showing that over there. I haven't actually done any calculus. I have done some algebra area. So this is definitely an excellence kind of question where you are going to need to think about things and apply it. Okay, now that we have our h, we're actually not even finding surface area, we are finding the maximum volume. So I know that the volume of a cylinder is going to be the base times the height. So the base, it's a circle, be pi r squared, base area, times the height. Now I have 2 variables here. I want everything in terms of one variable. Handily enough, I have found out what h is in terms of r from my original question. I also did it, they gave it to us really. So the volume is going to be pi radius squared times 12 minus pi r squared over pi r. Okay, so now I have my volume. I have just put area of my circle and the height, base times the perpendicular height. I can now do some simplifying. Pi divides with pi. This r divides with one of those r's, so I'm going to be left with r times 12 minus pi r squared. Hopefully you're doing this on your own as well, and you can see that that is true. I'm now going to multiply this r in, so it'll be 12r minus pi r cubed. That is what the volume of my cylinder is. Okay, I've now got the volume. I can now maximize my volume. The question was saying, find the radius that maximizes the volume. So what am I going to find? The change in volume with respect to the radius. So I'm differentiating 3 pi r squared, and let it equal 0 to find the maximum. So 3 pi r squared is equal to 12. So pi r squared equals 4. R squared will be 4 over pi, and I'm just going to square root both of those, and obviously only take the plus of that because you cannot have a negative radius. So I'm just going to menu, enter, 4 divided by shift pi equals and the square root of that is 1.128. Okay, so that's R. You can now substitute that back to find the maximum volume. So the volume we said is here. So the volume is equal to 12 times 1.128 minus pi times 1.128 cubed, and you can chuck that in your calculator and find the answer. So there we have it. Hope that all makes sense.